So yeah, I was just saying you
I'm
always
here.
get a short draw because you have to stay up late from Japan. So, but thanks very much and for joining us. And David will be telling us about electrically conductive sintering adhesives. So good luck.
Yes.
If you're ready, share your slides, and we are really over
Okay.
time. So please keep it to the times. And yeah.
Let me jump back into my script here. Okay, so I'm Dave Dewey with Fujikura Kasei. Today I'm going to talk to you about some of our newest non-nano silver sintering adhesives, and then just a little bit about our package level EMI shielding. I wanted to talk about these materials today because the overall theme of today's event is innovation, and as a material maker, our adhesives are used in a wide variety of applications, but we're a bit upstream from the cars and household appliances that utilize our materials, so we're engaging in constant incremental improvements. And these improvements have a ripple effect on innovation. Better adhesives allow for smaller, more efficient devices, which in turn allow new designs and innovations in a variety of fields. So the materials I'm sharing today are conceived by us as being used to improve the designs of semiconductors and other devices, but we believe the incremental improvements they enable will spur on new innovations down the line. So first, let me introduce Fujikura Kasei briefly. We're a Japan-based producer of polymer materials for a variety of applications, developing value-added products based on our decades of accumulated experience. In my division, the Electronics Materials Division, we make DOTITE. DOTITE goes back quite a few decades. We were the first in Japan to make electrically conductive adhesives for electronics all the way back in 1957, and our materials have contributed to the development of electronics around the world since. Okay, and next slide, please. So briefly, what is DOTITE? DOTITE is a combination of binder resin, functional filler, solvent, and other additives to improve performance. We refer to it as paste in Japanese, but variations can be used as adhesive, paint, or ink. Okay, next slide, please. So today I want to introduce our non-nano silver pressureless sintering adhesives. These are AA1901E1 and AA1901JE1. These materials are made without nanosilver to avoid any concerns with the health effects of nanosilver particles, and they're designed to sinter at relatively low temperature without requiring additional equipment to apply pressure when sintering. They're a suitable replacement for both lead-based and non-lead-based solders, avoiding the issues of lead regulations and bans, the remelting of non-lead solders, and the high temperatures needed to apply some types of solders. Next slide, please. AA1901E1 is 93% silver and is a resinless adhesive. Because it's resinless, the applicable substrates are limited to primarily gold or silver, but its adhesive strength is provided by the sintering process alone. It can achieve 11 newtons per millimeter square of adhesive strength when cured at 200 degrees for 60 minutes. It has a high electrical conductivity, 4.4 times 10 to the minus 6 ohms per centimeter, and excellent thermal conductivity, 200 watts per meter Kelvin. It can be sintered with pressure or without, offering the benefit of a sintering paste without requiring additional equipment, and a versatile die-attached material for power devices, semiconductors, and similar applications where both electrical and thermal conductivity are necessary. Okay, next slide, please. Like many of our electrically conductive materials, AA1901E1 performs slightly better when cured for longer and at higher temperatures, and you can see how adjusting the sintering conditions from 200 degrees for 1 hour up to 220 degrees for 2 hours can improve the adhesion. We even have some data for sintering up to 8 hours, so we don't really expect anyone to do that, but you can see how it improves the performance. Okay, next slide. AA1901JE1 is a 95% silver, non-nano, half-sintering paste designed with a high heat-resistant resin as a pressureless sintering adhesive. The additional adhesion from the resin allows it to be used in a wider variety of substrates, such as glass and copper. This gives it